the industry doesn't yet have a shared framework for measuring and reporting AI's water footprint in a consistent way. So without consistency, we cannot measure, and until we measure, we don't know if what we're doing is the right thing or not.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software.
Hello and welcome to the Week in Green Software, or TWiGS, your weekly wrap-up of ideas, research, and debates shaping how we build software in a climate-conscious world. My name's Eddie, and joining me today is the ever-amazing Valeria Salas. How are you, Valeria?
Hi, everyone. Hi, Adi. It's great to be here. I'm okay. It's very warm in Italy these days. So...
Why is it warm?
I don't know why.
Because of data centers?
Maybe. I don't know. We will be talking about this like in a wrap-up of the episode, maybe.
Yes, it is getting quite hot, and it's time to dive into an even hotter episode. We've got a very packed episode this week. We'll be diving into a brand new taxonomy of energy smells in code. Yes, your software and the architecture might stink, and you might not even know it. And we'll explore whether AI is quietly racking up carbon debt and how second-order effects are becoming more and more important. Next, we'll talk about the blind spot in AI's water history, because energy is not the only constraint that matters. AI data centers use land, water, and energy. And I think it's time that we take a look at all three. And finally, we will take a look at whether technical debt is actually carbon debt in disguise. Very interesting ideas in this episode, so hold on to your chairs. If you've ever wondered whether your pipeline, that is your CI/CD pipeline, is leaking watts, whether AI's climate promises add up, or whether that messy legacy service is secretly costing you a tremendous number of kilowatt hours, you're in the right place. Let's dive right into it. Okay, so I would like to first start with this topic that I think it's a beautiful research paper. The paper is called "What's This Smell? A Taxonomy of Software Energy Smells." And this is a recent research paper that came out from University of Dalhousie in Halifax, Canada. This study pulls together 12 categories of code patterns that tend to waste energy. Essentially, a catalog of energy smells in software, quite similar to what experienced architects would call code smells. This paper tries to develop what they call as energy smells. And what's useful here is the framing. It's not just about blaming the engineers and developers. It's about naming repeatable patterns so teams can detect and fix them systematically. If this matures into tooling and linters, it could make energy a more normal part of code review, like we already do performance and security reviews. What do you think about energy smells and linters, Valeria?
In previous episodes, we often have talked about practical things that developers can do, because sustainability sometimes remains a theory, something theoretical, but it's not. We've discussed about tools, examples, tests, and so on. And so if I had to talk to my younger self 4 years ago that started with sustainability and had to also convince my colleagues, my team, I would be super happy to share a linter or something that can test right in the moment the software that you're writing, the code that you're writing, right in the CI/CD pipeline. Just like you've said, we have tools that can check the security, the performance, and that...
Why not energy?
Why not? It's a missing puzzle piece. And so it would be great to have specific checks that we can have and we can build it would be a great idea, I think. Yeah.
I completely agree with you. I completely agree. And what you said, that this kind of feedback really helps people. It's what's called a short-term feedback loop, in which you make a change and you can immediately see the impact of that change. And people respond to short-term feedback loops much faster than a long-term feedback loop, right?
Yeah,
So-
definitely. Yeah, it would be very useful not only just for the specific development, but also if you want to maybe have like people like dashboards. Like if you want to have a dashboard on how like your software behaved like in the last, I don't know, 3 or 4 releases, you could do that by having those type of tools that run every time that you make a release, for example. Because it's not, the focus doesn't have to be like every time having better numbers. It's not that, because you could have like worse numbers because of so many reasons, no?
Yes, exactly.
But you should be aware of those numbers. Like
That is the
we've
first
made,
step.
yes, it's always the point that we have to make smaller steps in order to reach a bigger and a more a more structured process. And
I
so
completely agree.
yeah, it's such a great research, these ones, and I really like the parallel that you made with code smells, because at the end of the day, energy smells usually are very correlated with code smells. So
Thank you so much for mentioning that. I mean, I love that point that energy smells are correlated with code smells. And I think in one of the previous episodes, we discussed how certain compiler optimizations can reduce the energy consumption of an application by a lot. That is around 50 to 60%, while reducing performance by only 5%. So you increase the time by 5%, but you reduce the energy by 50 or 60%. And that is fantastic. I think that's a great way to look at the full picture instead of just one number that we think of as performance.
yeah,
For those of our listeners who might not have enough time to read the whole paper, I would also love to mention one more tiny fact so you would be, maybe you get interested. I love the pattern that this paper identifies as unnecessary memory usage. For example, they say that creating excess short-lived objects increases the garbage collection pressure, which leads to higher CPU wake-ups due to frequent garbage collection calls. Garbage collection is a quite CPU-intensive process, and with frequent GC calls, you increase the program's overall energy use tremendously. That's fascinating. I love this because I worked on garbage collectors some time ago, and I can see that they're quite CPU-intensive. Another smell that they mention is poor data reuse. For example, if you use your data poorly, if your operations have poor arithmetic intensity, you would be doing a lot of memory accesses, and memory accesses are actually the bottleneck in today's systems. If you work in computer architecture or if you design these AI accelerators, you would quickly understand when I say AI is memory bound. It is not compute bound. We need better memory systems. But this is not a computer architecture podcast. This is a Green Software Foundation podcast on sustainability. So I would have to hold my horses. Valeria, what do you think about what is the next step from this? Would you love to have this kind of CI or CD linters?
If I had to, I would definitely suggest to my clients to use this type of tools.
That would be a great idea.
Not only because it would make my job easier by having data and by having information of how things are doing and how we could make them better, but also because, as you were saying, sustainability in general. We talked about this a lot, but sustainability in general is an umbrella term. But what I love about this topic is that it's actually about looking at things from a different perspective. And so what I love is that on the practical side, we would have tools super useful on the more practical and technical side. And on the other side, it would make people more aware of the things that they are doing. And by making them more aware, you are basically diving into a rabbit hole. Because in this topic, the first time that you learn something, you want to go deeper and deeper and deeper in the topic, because you could go from, I don't know, from a more broader data to a process level data, for example. And so I would love to have this type of tools. So please, researchers, do a lot of researches about this.
I love the fact that you mentioned a process level tool instead of just a data. I think that's the need of the hour. People should understand the process overall as compared to just one part of it. That's a fantastic point. And that actually brings me to the next topic that we want to discuss. Is AI building up a carbon debt? So we have a paper from MIT, that is, for our listeners, Massachusetts Institute of Technology, where the researchers have argued that AI is accumulating carbon debt. The emissions are happening right now, while the promised benefits are either uncertain or pushed into the future. The core tension is timing and proof. Training and deploying the models creates immediate load, right now on our land, water, and electricity. But the offsetting gains, the improvements that are projected to come from AI, require real adoption. They require real displacement of high emission activities. For example, oil and gas well finding, and credible measurement, right? It's a helpful push to separate possible benefits from realizable, bankable benefits. What do you think about that, Valeria?
It's such an interesting topic, this one. It happened to me so many times to talk to people that said, yeah, but AI could be super life-changing or climate-changing on a positive note. So we would have to invest our computational resources and resources in general today in order to have a better life tomorrow. But what I always try to point out to people is that we are investing with resources that we actually do not have right now.
Exactly.
Because our planet is already in debt. Yeah, it's already overloaded. We are already, I don't remember, but a couple of weeks ago was Earth Day, and I saw so many social media posts and so on. But for example, the overshoot day, every year in our countries, we are moving from 2 days a year, 3 days a year, and it's I think that people are not facing this issue. Because in some parts of the world we are lucky enough to not see so many of the negative impacts that technology has. But it's just a matter of time, and it's people. I don't want to be the negative person. I just want to be critical aside from for these topics, because what I try to share with people is that if we want to call something innovation should be something that brings positive things. And of course, we always have to invest resources, money, time, space, what we want. But the positive aspects should always be more than the negative aspects.
I agree.
And so my point here, and what I was also sharing with Adi before recording, is that with AI and with the hypothetical positive impacts that AI has versus the negative impacts that we are creating today for like the next
The future
20
generations.
years, future generations,
Exactly.
and so on. We are basically having a bet with nature, with our planet.
Yep.
And we will never win with nature. Like nature
impossible.
always will come to humans. And so, like, again, I don't want to be the negative person here. I just want to be critical because I love technology and I love these type of topics, but I also would really love for my nephews and for their children to see, for example, the mountains the way I see them today.
Exactly.
And I know that the planet will change. It's the circle of life. It's the circle of nature and so on. But it makes me sad to think that we are maybe not looking at the important facts, and we are just focusing on, yes, but maybe in the next X years, we will change the world. We will be able to, I don't know, make our lives longer and so on. But my mind created a connection with the things that I've said before. And the thing is that
Tell us.
we as humans, we only think about ourselves.
Yes.
We tend to not
Exactly.
think to other people, whether they are, whether we are connected to them or not. We tend to not think about what is around us when we are thinking about hypothetical benefits for ourselves. And so, yeah, what do you think, Adi? I stopped
completely
being the
agree.
critical.
No, this is not being critical. This is being realistic. This is saying out the things that no one wants to say, but everyone wants to hear. I completely agree with you. So, as humans, we are incredibly short-sighted, and it's
Yeah.
important that we at least consider the future. That's all.
Yeah.
I also think this paper is quite interesting in the fact they mention the theme, what we discussed right now, but they mention this in the context of what we popularly call as the butterfly effect. So if I paraphrase the paper to some extent, most current AI applications are emissions intensive. They do account for potential hardware and algorithmic efficiency gains and targeted deployment in energy and climate critical systems that could deliver climate benefits in many use cases. However, and this is a butterfly effect, emissions today have significant downstream effects that persist and change climate for generations, whereas neutrality is measured for the next accounting year. And here's the gap, right? Our financial and accounting systems are built on the next quarter, the next year, whereas the downstream effects are for centuries. And I love this kind of second order thinking. This is very important to truly understand the impact of our actions.
Yeah. 100%. Like, I could tattoo this part, like, on my shoulder. I don't know.
That will be great.
But yeah, the thing is that and by also another thing, I want to point out that we as individuals have some type of power because our choices like lead the market, lead how companies behave. But with this topic, governments and big techs and like big companies and like those who have more power than normal people have their role. because, for example, and this is 100% related to AI tools. Like, AI tools were not asked for. AI tools were thrown into the internet, and like big techs said, go for it, use them. Like, we won't give you any guidelines, any instructions, any information related how these type of tools will change how you think, how you write, how you, I don't know, any
exactly correct.
activity.
Yes. People are losing the ability to think. They're losing the
Yes.
ability to write. Yep.
Yes. And so, and this is happening right now.
Right now.
It won't happen like in centuries. This is happening right now.
Right now.
And-
Exactly right.
And we also are not able to say how things will change in the next, I don't know, 6 months, because
Yep.
technology is super fast. And so in this regards, we have definitely a decisive role on how things can move on. And so me being critical, I hope that people that will listen to the podcast will think about our reflections. And maybe
That's the hope.
they, I don't know, they work for big companies, or they know someone who work for a big company, or they have connections with someone in our governments. I don't know.
Yes.
But I think that these type of issues have to reach the people that really have power.
I agree.
And so, yeah, I don't know. Let's hope for the best, as usual.
Let's hope for the best and keep talking about it, because only by talking about it is we're making the effort to get to the right people.
Yeah, definitely.
Now let's take a look at another topic that we have for today's episode. And this was a very fascinating read. This was an article on LinkedIn where there was a panel of discussion at a conference. And the panel tried to understand how much water AI infrastructure is actually using. So these are all experts in their fields, top engineers, management people, scientists. And the panel starts with a simple question. Can we try to understand exactly what is the number that AI infrastructure is using for water? And nobody could come up with an answer. Nobody knew how much water is being used. And that was fascinating, because this means water is a blind spot. The issue is not a lack of data, but a mismatch in how the system is being measured. Energy has a complete ledger. We can track the generation, transmission, and consumption with precision. In fact, we know down to the kilowatt hours how much energy is being produced and consumed at each stage. However, water does not have a ledger. We don't know, or we don't understand how the difference shapes the system. And what is missing is a shared frame for evaluating efficiency at the entire system level. What do you think about that, Valeria?
I think that we talked about this at least one more time. But yeah, water is, we have some data, but it's always a missing point. It's always something that companies do not report, do not how to report. And this always comes to the problem that we don't have a complete framework. We can see in the various reports that sometimes we are making we are evaluating different things using different metrics. And so this is definitely a problem. And usually another thing is that when we generally talk about environmental impacts, people tend to connect environmental impacts with energy or carbon in general.
Yes.
We never see as the first point that is talked about. We never see water. We never see other type of resources. It always comes to specific analysis and specific topics. And so definitely it's a missing point. And it's very scary because we as humans, our lives are very connected with water. We need
They're
water
dependent
to
on
live.
water.
Yeah.
We need water to live, exactly.
Yes. And so when I read this article, something like stuck in my mind. It was a comment under the original post, and I noted it because I forget everything. But the person commented under the original post, so everyone will have the links as usual, so you can always look at the comments and look at the discussion.
The links just down below.
And what this person wrote was, AI infrastructure keeps scaling and the water bill scales with it.
Yes.
Every conversation about water usage in tech eventually lands on better cooling systems, better facility designs, better location choices. All of that matters, but it starts from the assumption that the compute running was compute that needed to run.
Yep.
My mind was blown up by this sentence. It's a super easy sentence, but it's very important because aside from measuring, reducing, and understand what our impact is and our data, we always have to ask ourselves, ask our team, ask our managers, do we really need to do this? Yes. Is this really useful?
Exactly.
And so before any other analysis that we have to do, that's right. That's the reason because most metrics regarding carbon do not take into considerations carbon credits or carbon offsets, because with those we are not actually reducing anything. We are living our lives in the way we want, and then we're like, yeah, but let me offset my 100 travels during the year with, a forest on the internet. That doesn't make sense. That doesn't make any sense, people, please.
Exactly.
And so, first things first, ask if what you're doing actually is useful.
Yep.
And if those resources that you are using are actually needed, or if you would use them for something else.
Yep.
And so, what do you think, Adi, about this?
I love
Again,
that
I'm
point.
being critical.
No, I completely agree with you. And we need someone to be critical, right? Like, you're exactly right. I completely agree with you. And this is something I wanted to just add to this is that the article says the same thing. The article argues that the industry doesn't yet have a shared framework for measuring and reporting AI's water footprint in a consistent way. So without consistency, we cannot measure. And until we measure, we don't know if what we're doing is the right thing or not. We're just doing something for the sake of doing it. And we don't know.
Yeah. And also, like, doing things nonstop is very connected to how our society is right now. Like, we cannot stop. We cannot stop doing, like, if you have, some free time during the week, sometimes you feel bad for not doing things. But humans, our brains need to stop, need a blank space, need a blank time. Because in that moment, our mind and our skill to think actually blossoms, rather than when we are full of thoughts, full of things that we are afraid of, and so on. So
I completely agree.
So, my suggestion would be, listen to this podcast, of course, but maybe the best thing that you could do would be listen to this podcast when you're like walking in your town, I don't know, and like having a walk after a tiring day at work.
Yes. Yes. Slow down.
Yeah,
Savor the moment. Live in the current second and observe things for how they are.
perfect. I cannot add anything else to that perfect sentence.
Well, if you cannot add anything else, then I have to switch to the next topic. So
Yes.
the next topic is the cost of faster and greener computing and why technical debt is carbon debt. And this article is a blog post written by an attendee at a sustainability conference recently. The conference was called Sustainability Conference for Responsible Research Computing at CERN in Geneva. For our listeners who are not familiar with CERN, CERN is the organization responsible for research in particle physics. If you've heard of the Large Hadron Collider and the Standard Model of particle physics, a lot of great work is done at CERN. And this was a great conference focusing on the carbon emissions from research. So there were scientists and researchers at the conference trying to understand how to improve and reduce the carbon emissions from the compute that they use for this data. There were a lot of interesting ideas. GPU efficiency, the reality that greener often comes with trade-offs, and a very, very sharp idea that technical debt is actually carbon debt in disguise. And that's a very interesting chain of thought. The logic is that messy systems force extra compute. You would end up with duplicated pipelines, inefficient default settings, a brittle architecture, which wastes time for developers, which essentially leads to more compute and energy being used, and repeated workarounds or band-aids, which don't scale with time. So it's a very interesting idea to remember that sustainability is not just about the hardware or the cloud choices, it's also about the ability to maintain your code and to do work at a reasonable pace, which is sustainable for the team and for the environment. What do you think about that?
I think I always reply with this, but I love so much these topics. And I completely agree that, as we always say, sustainability is an umbrella term. Yep. It can mean so many different things, also be based on how a company works, how are the processes in a company, and so many more different things. And these thoughts recently also led me to create a newsletter on LinkedIn. So if anyone is listening to this podcast, you can find me on LinkedIn by my name. And the name of the newsletter is Sustainability Beyond Carbon. And my idea was, I want to try and translate sustainability with all the other things that do not mention sustainability, yep, but they are highly correlated with sustainability. And the funny thing is that technical debt was actually my first topic, because technical debt is something that every team at some point has to face. And so, as you said, technical debt is creating messy and monsters with your code. And at some point you're like, I don't remember even writing this thing.
Yes.
I have to
all the time, yes,
manage this and order, make some order in my code and so on. And so I always try to translate sustainability into more practical things. And it takes some time. It takes some time because you need to understand so many things from different perspectives. Like, one of the things that I think that facilitates me in my job is that I have a background in software development. And so I wrote code I wrote queries that were like very, very bad and like retrieved data that I didn't need and so many more things. And so I try to connect the dots between these topics. And we are actually connecting the dots with our first topic of the day, which was the linters and so on. So I think that is perfect. But yeah,
That is perfect.
Wrapping up this news, I do think that by seeing sustainability as a broader topic, as a topic that refers to many more concepts, sustainability can become one of the things that we actually think about without thinking about it specifically.
Yes.
I don't know if that makes sense. In my mind,
That
it
makes
made
complete
sense. Perfect.
It is so deep inside the head that you don't have to force it. It comes out on its own.
Yes, you explained it better than me, but my thoughts sometimes are like, I don't know, make some little monsters and yeah, but
It's okay.
yeah, 100%.
Okay, that's perfect, right? So thanks a ton, Valeria. For our listeners, that's it for this week's episode of TWiGS. We covered energy smells and code, AI's carbon debt, the missing water metric story, and why technical debt can also look like carbon debt. It was really, really great to have you all here. And as always, I'm super grateful to my host, Valeria, for joining.
Thank you, Adi. It was a great episode, great topics, great conversation. And yeah, everyone, if you're listening to the episode and you have feedbacks, you want to keep the discussion open, please do share the episode. Like, I don't know, share what you liked about the episode, or if you have any other ideas related to the things that we shared, please do. Because I feel that every time that we discuss more about sustainability, we open more the topic to the broader audience. And so please do that.
We would love that. And as a final reminder, all the resources for this episode are in the show description below. And you can always visit podcast.greensoftware.foundation to listen to more episodes of Environment Variables. That's it for today, folks, and see you all in the next episode. Take care, and bye for now.
Bye.
Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show, and of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.